All right, let's get started on this new 2.2 lesson. We are starting with a lesson on exponents and all of the exponent rules. Hopefully some of these or all of these are a review from middle school. So remember that when we're talking about exponents, repeated multiplication, like 2 times 2 times 2, can be shortened with exponents. So this base, the big number 2, to a power, the little number 3, is what we're talking about when we say exponents. So the base is the big number at the bottom, and it is a number in exponential form. It appears beneath the exponent. So let's write a couple examples of a base, like a big X to a power of 2, or a big 2 to a power of 3. So the base can be a letter or the base can be a number. So this base is right here. Now the exponent is a small number in the sky. This small number in the sky tells us how many times to multiply the base. By itself. So it's a small number, tells us how many times to multiply the base. And so this exponent, let's use this color, is this little number in the sky. An exponential expression is just an expression that involves an exponent. It may contain variables. So the base may have an exponent. But when the power is an exponent, it equals an exponential expression. And so what would that look like? That would be like y equals, begins with 2 times by 3 every time to the power of x. So this is our exponential expression. When the power is an exponent. And a fractional exponent is what we're going to be talking about in this chapter. So it has to do with a fraction. And so it would be like saying x to the power of 1/2. And we are going to be converting fractional exponents back and forth into radicals. So x to the power of 1/2 equals the square root of x, or x to the power of 1/3 equals the cubed root of x. This is the kind of thing we're going to be talking about this chapter. So a fractional exponent looks like a fraction in the sky, that little number. All right, here comes a power. This is a small raised number that tells you this is basically the same as an exponent. And it's the small raised number. that tells us how many times to multiply the base by itself. And so a power is the same as an exponent. The principal square root is the positive square root of a number. Okay, what do you mean by that, Ms. Sanchez? If I say what's the square root of positive 25, I could say that that's positive 5 times positive 5 that equals 25, right? So the answer could be 5. But can we also think of another root of 25? Well, isn't negative 5 times negative 5 also able to give me 25? So there are two square roots of 25. There is positive 25 and there is positive 5 and negative 5. So two roots, negative 5 and positive 5. So what's the principal square root? The principal square root is just the regular normal positive 5. Finally, the radical is the symbol, this symbol we use to indicate square root. It's this symbol. So when I say radical, we're talking about this symbol right here. Okay, so now let's go look at some practice here using the visual clues. All right, so label each part of this diagram. So this little b to the n is our exponent or power, and the b is the base. Label those guys. B to the n is called an exponential expression. The base tells what number to multiply by itself, and the exponent tells how many times to multiply that number. All right, here's this repeated multiplication that we are going to be summarizing. So here, the 5 is my number that's multiplying. That's going to be my base. The exponent is how many times you're multiplying that. So this expression would become 5 to the 4th. But what is the value of 5 to the 4th? What is 5 times 5 times 5 times 5? It's 625. Do the next one. 7 is my big base here. 1, 2, 3 times, so my exponent is 3. 7 to the power of 3 is 7 times 7 times 7, which equals 343. My big base on this next one is 2. It's being multiplied by itself 7 times. 2 to the 7th, do that on a calculator, equals 128. 9 is my big base, multiplying by 2. 9 to the power of 2, and that equals 81. This time, big base is 3. We're multiplying it 5 times. So my exponent is 5. 3 to the 5th is 243. If you're not sure where these big numbers are coming from, it's going out and multiplying this expression out. Okay. Number the following operations in the order they should be done. So do any operations inside grouping symbols first. And then we're going to evaluate any exponential expressions second. Then we do all multiplications and divisions, and then we do all additions and subtractions. This is our PEMDAS, telling us what order to do the operations. Use this list above to fill in the order of operations in this flowchart. So do any operations inside grouping symbols. Next, evaluate any exponential expressions. Do all multiplication and division. Do all addition and subtraction. Okay, now before we finish this next part, because this one's a little bit longer, I'm going to stop the video here just from this note-taking part before we get into actual practice. So this is just part 1 of 3 of the videos for this week.